This is the Pentax Optio E10 digital camera. This camera was manufactured in the year 2006, and it's fairly typical of cameras of its era. It probably sold for around $100 new at the time. Today it isn't worth much. Most cell phones have cameras that are superior to this one. I picked this up at a local thrift shop for all of $3. I think it's convenient to have a little camera like this around. Maybe keep it in your car, or keep it at work, keep it in your office, whatever, for the occasional use when you may need a camera, particularly when you can pick them up so cheaply. Now, here's a problem I'm having with this camera. It seems to read the voltage on the batteries incorrectly. I have two fully charged AA alkaline batteries in here. They both measure 1.5 volts. But when I turn the camera on, I get this. Now, this symbol is telling me that the battery is almost dead. And sometimes when I'll turn it on, it'll shut off immediately or it won't come on at all. For some reason, it's not measuring the correct voltage. Now, I suspect there's a voltage drop somewhere. It could be with the battery contacts. This camera was manufactured in early 2006, while Pentax was still an independent company. At the end of 2006, Pentax was bought out by the company called Hoya, H-O-Y-A, an optical company which made a lot of things, including medical imaging equipment, endoscopes, and things like that. In 2011, they spun out the camera division from Hoya, and it was purchased by Ricoh, R-I-C-O-H, Ricoh, the people that make printers and copiers and things. And they are continuing to make Pentax cameras. But Pentax itself, as an independent company, no longer exists. This is now a subdivision of Ricoh. But I doubt that Pentax actually made this camera. I also happen to own another camera which is almost identical to it. Again, from 2006. This one is branded as Sanyo. The similarity between the two is quite striking. It's all laid out about the same. Little timer light there, and we've got our flash there. We've got essentially an identical lens and shutter mechanism. You look at the top, and it's got the same arrangement, same circular switch with the same symbols in the same order, and the same button to take the picture. And we got the on-off in the middle of the circular switch. And here on the back, exact same screen size. We've got the the zoom buttons, which are the same, and they've got the same symbols on them. We have the circular, we have the circular button here with the same symbols on it. A few differences. The OK button on the Pentax was moved to the center of the circular switch on the Sanyo, and the trash can button was moved from here to here. And the menu button was moved from here to here, but otherwise strikingly similar. And we look on the side here, and we have our USB ports, again, in the same place, looking identical. And if we turn the cameras on, what we find is the menus look exactly the same. Look at that, exactly the same. Wow, exactly the same. One very interesting difference. In the Pentax, the firmware version says 1.0. In the Sanyo, the firmware version says 1.03. So the difference is this one's firmware appears to be slightly newer. Another difference, the Pentax has a socket for an external power supply, which the Sanyo lacks. And then the memory cards, the Pentax takes an SD memory card, but the Sanyo can take an SD or a high-capacity SD card. Also, interestingly, the batteries are reversed, minus plus, plus minus. But the similarities are so striking. I'm sure that these two cameras were made by the same company. even though these are both Japanese companies, the cameras were made in China, both of them. Probably a contract manufacturer of some sort working for both of them, making nearly the same camera. Whoever made this camera for Pentax made a nearly identical camera for Sanyo, and who knows how many others. We're going to go ahead and take this camera apart to see if we can figure out why we're having this voltage problem. And we will start, of course, by sliding open our battery cage and removing our batteries. This is the tricky part about disassembling this camera. This little strip of metal right here, this is going to fool you. What you can't see is that there are two screws underneath this metal strip. Now there are two screws here, and there's two screws here, which we can clearly see. What you don't see are two screws here. Okay, they're right about here. You got to get this thing off first. What you want to do is you have to start prying at this end. But you got to get something underneath this and lift it up a little bit. This is how this starts. Okay, so I've got it started now. At this end, I can now push and take this off. Okay, there's a couple little slots here that are holding that piece in. And that exposes these two screws. Not at all obvious that they're there, and not at all obvious how to get this thing off. And now we've got 6 screws, 2 and 2 and 2. One thing to notice is this one is black, all the others are silver. We will go ahead and remove those 6 screws now. We've now removed all 6 screws. We have 5 identical silver coarse threaded screws and 1 black fine threaded screw. The coarse screws go into plastic and the black screw goes into metal. Now, one thing I like to do is when I'm working on small things like this, these tiny little screws, I like to save these little screws in some kind of a container. I like to use old pill jars. If you drop that into the carpet, you'll probably never find that screw again. Now it's just sort of a matter of prying things apart carefully. It's starting to come apart. It's kind of hard to do this without damaging something. These cameras really weren't designed to be taken apart. It wants to snap itself together and not be unsnapped. There's a clip right in here that's really kind of holding it. There we go, we got it. Right there, there's a little clip that's very stubborn. Okay, that got it started pretty well. And once you get this one here unhooked, then the whole thing sort of pops open. Now along the top, we've got some resistance here. And there we go. Excellent. We have the top and bottom separated now. There we are. Now that we have all the screws out and we have the front and back pried apart, we can see that we have a cable holding that front end, and we have to be very careful with that. If we damage that, our LED screen will be ruined. Okay, there we are. We can get a better look at that now. And there's our LED cable there. The cable is attached right here. This cable is attaching the whole back of the camera. We need to flip up this connector here in order to remove that cable. You have to kind of get your fingernail under it and kind of flip it up like that. Okay, and there, that got it. Now it's come off. Here's our memory battery right here. This is the battery that keeps the time and date. And amazingly, this battery is still working after 12 years. 12 years and it's still holding charge. Now, if you have to replace this battery is called MS614. That battery right there, MS614. It's 6.8 millimeters in diameter and 1.4 millimeters in thickness. It's a 3-volt rechargeable lithium battery. Now that battery is soldered in place at 2 points, the positive and negative terminal. That should probably come off very easily if you need to replace it. This is a web page showing the time and date memory battery, the MS614SE. This one is made by Seiko. The purpose of this battery is to retain time and date even when the AA batteries are removed. In this case, the battery is still functioning after 12 years, which is quite remarkable. But these batteries will eventually fail. So if your camera is losing time and date whenever you pull out the AA batteries, that means this lithium rechargeable battery has gone bad. Now you could simply live with it and just, re-enter the time and date every time you pull out the batteries, or you could replace it. These batteries are available, and it would be pretty easy to desolder and resolder one of these batteries. It comes with terminals already welded onto the battery. Okay, now on the side here we have this one screw. This is one of the things holding the front panel on, so we'll go ahead and remove this screw here. Now there are 2 screws holding this electronic body to the front panel. Here and here. We need to remove those screws. These are very long screws because they go from here all the way to here. We'll go ahead and remove those now. We can see how long those screws are. Now we can start to work the electronics out of this front case. One thing to be careful of, this little diffraction grating will fall out of place once you move the electronics back a bit. Now, as you're separating the front case from the electronics, one place it hangs up is right here, where the tripod screws in. You have to kind of lift that up a little bit to kind of get that out of the way. It's hanging up right on that thing. Looks like it could break real easily. Alrighty, there we go. This little piece of trim here is held on by 2 screws right there. We don't really need to concern ourselves with that. Some of these pieces here are held on with glue. Never a good sign. Okay, well that's out of the way. Now we have the electronics package exposed. Now a couple things to observe. Here's our lens. And this structure right here, this is the capacitor which drives the flash. This capacitor holds a very high charge. You've got to be real careful around that thing. It doesn't appear to be exposed anywhere. I have touched these before, and I'll tell you, it's like getting hit with a taser. It'll just throw you across the room. Now they've got this tape on here, which is covering all those connectors. That's good. You can see these 2 wires coming out of that capacitor. One end is pretty exposed. The other end is buried deeper in there. But anyway, now something that I have noticed here, we have this bluish crystalline material on this electrode right here. This is one of the battery electrodes. And also some material here. This indicates that there's been a battery leak in the past. We've got this bluish material all over this connector here. And I suspect that may be why we're losing voltage. This may be the reason why our voltage is being reported lower than it is. It may be getting lost in this connector here. I'm going to try to simply wipe some of this away with a damp cloth. This bluish color to me indicates that it was an alkaline battery that leaked. When alkaline batteries leak, they leak the electrolyte, which is potassium hydroxide, and when it interacts with copper, it produces this bluish color. This stuff is very water soluble, so maybe we can get a lot of it out with just a moist rag. But always remember, we've got this little monster right here, so let's make sure we don't accidentally discharge ourselves onto that. Now, just to be safe, I've gone ahead and put a rubber glove on my right hand. It looks like there's a lot of this material inside, deep inside of that switch. When you have an old worn-out toothbrush like this one, it's good to hang on to them because they're great for cleaning small parts. Some of the more stubborn material, you might just sort of try to knock it off with a small screwdriver blade so we can establish a good, solid metal contact with the battery. I bent this terminal up here a little bit, opened it up a bit. Boy, you can really see a lot of that bluish material has really lodged itself in there. I have to do some scraping to get that out. We've scraped out a lot of that material. Looks like we have better metal contact now. It looks like there might be some material under here that looks like maybe leaked battery material. I'm going to go ahead and remove this button mechanism, which is held on by screws here, here, and here. Well, just as it appeared, there is a fair amount of this crystalline material underneath this piece of tape. We'll see how much of that I can just scrape out of there. This is going to take a while. Well, I've gone ahead and scraped a lot of that battery material out from here where the button was. And I've gotten a lot of that material off of this battery terminal. Unfortunately, the combination of the corrosion caused by the leaked battery material and just the flexing of this thing that I had to do in order to open it up and clean it, I have basically cracked it. There's a crack right along back in there, and this thing is about to fall off. It's being held on by just a thread. I don't think that's going to last. I think that's going to fall apart. I went ahead and just broke it off. Well, a combination of corrosion and metal fatigue, I managed to snap it off. So this spring mechanism is no longer working. I'll have to figure out some way to repair that. In my box of junk parts, I've got this old battery cage for one of these cheap Chinese LED flashlights, like one of these. This thing holds 3 AAA batteries. I wonder if I can't cannibalize one of these terminals with a spring on it and maybe somehow mate it with that metal tab, and maybe I can repair my connection. Let's see what I can't do with this. Okay, I've taken one of the terminals out of this battery holder and I've sandwiched it in here. A portion of the spring remaining. It's pretty tight, but I think it's going to work. Hopefully repaired, we will go ahead and reassemble our camera. Now the first thing we have to do is put our button back on. The picture is I put that button back on and I put the 3 screws back on that hold it. Next we will put the front face on. This little diffraction grating here which goes over the flash. I'm just going to sort of hold that in place and then place this over it this way. Maybe gravity can hold it in for us as we try to get all this together. Okay, we got that snapped into place. Now that the front shell is back on, we will fasten it in place. This is the smallest screw of all of them, and it goes right here. And then the 2 longest screws, and they go here and here. I'll go ahead and screw those in. Next we have to put the back shell on. tricky part is going to be connecting our flat cable. We flip this back. Okay, got it. I got that hooked in there, and then pop that down. Okay, good. There's kind of a slot in there. You got to slide it in as deep as it'll go, and then you can pop the little lock down. Okay, now we carefully snap the front and back together. And now we can start putting all the screws back in. And now we have the 6 screws to hold the back shell on. 2 here, 2 here, and 2 here. And of the 6, 5 of them are these silver coarse threaded screws. One of them is the black fine threaded screw, and it goes there. Okay, with all the screws in place, we can now put this piece of plastic back over like so. It snaps into place. Excellent. Now, the last thing is to put our batteries back in. Let's go ahead and fire it up. Aha, it still works. And look at that. Our battery meter now shows we have a 100% filled battery, as it should. Excellent. So it looks like the corrosion on that battery terminal was, in fact, dropping our voltage. We had a kind of a mid-course correction there where we broke the terminal off, but we found a fix for it. So the alkaline batteries worked fine. Now I'm going to try this again, but this time with nickel metal hydride batteries. That's important because the nickel metal hydride batteries are a lower voltage. These are, of course, 1.2 volts instead of the 1.5 volts of the alkalines. And let's see if we still get a good result. Aha. Now it shows us 1 notch off. Okay, we've lost 1 notch on our battery meter, but that's, I guess, to be expected since these NiCads are a slightly lower voltage. Good. I think we've got ourselves a working camera.